mathematicians, it's Justin again. In our last lesson, you used unit rates to help me choose the most efficient car for my road trip. I'm ready to hit the road, but first I have some more planning to do. And we'll continue using unit rates to figure it out. Today's objectives, you'll calculate the unit rate from real-world problems and use unit rate to make predictions. Make sure you have your guided notes ready, and let's get into it. So, on my road trip, I'm planning to visit 3 capital cities. Since I'm currently in Atlanta, I'll start here. Then I'll make my way to Montgomery, Alabama, and I'll spend 2 nights there. Next, I'll travel over to Jackson, Mississippi, and spend 3 nights there. After that, I've got a long drive north to Nashville, Tennessee. I'll stay a good 4 nights there since there's a lot to see. And then it's back to Atlanta. Ooh, I'm on a tight schedule. I'm planning to go to attractions in each city, so I need to know how many miles per hour I have to drive to arrive on time for everything I have planned. First, from Atlanta to Montgomery, I'll need to drive 180 miles in 3 hours. I want to be there for a concert, so I need to figure out how many miles I need to drive per hour to get to Montgomery on time. Assuming I drive at a constant speed, how many miles will I drive in 1 hour, or per hour? We're just creating an equivalent rate here, so we need to divide both 180 and 3 by the same number. Since 3 hours divided by 3 is 1 hour, then we just divide 180 by 3. So I'll drive at a speed of 60 miles per hour. This is a unit rate. We talked about this in our last lesson. A unit rate is a rate where one of the quantities is 1, in this case, the 1 hour. Can you think of the other unit rate? It's also correct to say that there is a unit rate where the miles is 1. The 1 mile would make this a unit rate. In this case, we would divide both 180 and 3 by 180 to get 0.016 repeating hours. Although this is a unit rate, it is not nearly as useful as the unit rate of 60 miles per hour. Now let's look at these rates that represent my drive between the rest of the cities. Pause the video and find their unit rates to find the miles per hour I need to drive to get to each city on time. For Montgomery to Jackson, we divide 285 miles and 5 hours by 5 to get a unit rate of 57 miles per hour. For Jackson to Nashville, we divide 414 miles and 6 hours by 6 to get a unit rate of 69 miles per hour. For Nashville to Atlanta, we divide 248 miles and 4 hours by 4 to get a unit rate of 62 miles per hour. All right, to recap, here are the speeds I need to drive to stay on schedule. I'll be driving along the interstate highways, and their speed limits are generally 70 miles per hour. Looking at my driving speeds, I won't go over the limit, and I'll also get to each city on time. With all this driving, gas is going to be expensive. But thanks to you, we chose a super fuel-efficient car. We should go ahead and predict how much money I'll spend on gas driving from city to city. So, between cities, we know how many miles I'll be driving, and we know what car I'm using. What other important information do we need? Well, we need to predict how many gallons of gas I need to drive all these miles. So we have to grab the car's fuel efficiency information from our last lesson. What was that again? Got it. For every 1 gallon of gas, my car will travel 36 miles. What can we do now to figure out the number of gallons needed? If we figure out how many total miles I'll drive, I can then figure out the number of gallons we need. So let's add the miles up. 1,127 total miles. Okay, now we can use our unit rate to predict how many gallons of gas I'll need to drive between cities. These are equivalent rates, so we'll first need to figure out what number we can multiply 36 by to get 1,127. What would that number be? You can use a calculator here. To find what number multiplied by 36 gives us 1,127, we can divide 1,127 by 36, which would be 31.305 repeating. We multiply both numbers by 31.305 repeating. I'll need 31.305 repeating gallons to drive a total of 1,127 miles, but since I might take detours and pit stops, let's just round this up to 32 gallons. Now we can predict how much money I'll spend on gas to travel between cities. In those regions, the average price of 1 gallon of gas is $2.78. I'm predicted to use 32 gallons of gas. Pause here to find how much money I'll spend on that amount of gas. We know that we'll multiply 1 gallon by 32, so we'll also multiply $2.78 by 32 to get $88.96. You just used unit rates to help me figure out the speed I need to go and how much money I'll spend on gas going between cities. You know, I'll be staying overnight in each city too, so I'm going to need to predict how much I'll spend on hotels. Here are the number of nights I'm spending in each city. I've looked at some hotels and decided on these rooms. And here are the unit rates for the price per night. Use these unit rates to predict my total spent on hotels. You can use a ratio table to organize the information. Pause now and return once you have your prediction. For Montgomery, if it's $75 per night, how will I find the price for 2 nights? Since 1 night times 2 is 2 nights, then we can also do $75 times 2, which is $150. For Jackson, if it's $65 per night, then 3 nights will be 3 times $65, which is $195. Lastly, for Nashville, if it's $120 per night, then 4 nights will be 4 times $120, which is $480. Adding all these up will be $825, so that'll be the prediction for my total spent on hotels. Thanks to your help with unit rates, I was able to accomplish a lot of planning. Today, you used unit rates to calculate the speeds I need to travel to get to each city on time. You also used unit rates to predict that I'll spend $88.96 on gas and $825 on hotels. This, plus the $270 for renting the car, brings the total of the trip so far to $1,183.96. And with that, I'm off to hit the road. Don't worry, we'll continue to apply the power of unit rates to help make smart decisions during my road trip. See you next time!